Hello everybody, how are you? I'm Fatma. It's for mathematics lesson. We take before rules of derivative functions, but we will replay it again. I will give you the first rules about derivative functions. The first rule is about the constant. The first rule is about the constant. Okay, I'll explain to you. If I have a function y equal to k, if y equal to constant, like for an example, y equal to 3, if I want to take its derivative, the derivative of the function, it will be 0, always will be 0. Okay, if I had a constant, the derivative of the constant will be 0. This is the first rule. So how we write the derivative? We write it like y prime. This is called prime. Y prime. Okay, y prime equal to 0. Why y prime equal to 0? Because I said if the function is equal to constant, the derivative of the function will be 0. This is the first case. The second case I had, if we had a potential. What's the meaning of a potential? It's mean like a function with a power, like y equal to x to the power n. What will be its derivative? Its derivative will be n, it's n the power, multiplied by x, the variable, to the power minus 1, to the power minus 1. For an example, for the powers, y equal to x square, y equal to x square. If I want to take the derivative of y equal to x square, what I had, a potential case. What's mean a potential case? It's mean the function with a power, a variable with a power. So if I want to take this a derivative for this function, I will take the power. I will go back to the rule. I will take the power multiplied by variable to the same power minus 1. So y prime equal to the same power 2 multiplied by variable to the same power minus 1. It's always minus 1, not changing, ever, never. It's always minus 1, any power minus 1. So y prime equal to what? 2 multiplied by x to the power 1. We don't write power 1. Okay, if you get it now, we will take another example for the in the next minutes. So the second rule is we have potential case. If I had a variable to power to any power, so the derivative of this function is I put the power multiplied by the variable to the power, the same power minus 1, always same power minus 1. So the third case, we have special cases. For an example, if y equal to x, a variable, any variable, not only x, any variable to power 1, so the derivative of it is equal to 1, like this. For example, 3, for an example, y equal to z, any variable to power what? 1. So its derivative will be y prime equal to 1. Okay, this is a rule you have to save it in your mind. Why it's be like this? So if we take the same case of x to the power n, this is n equal to what? Equal to 1. So if I want to take its derivative, I put 1 the power multiplied by the variable 1 minus 1. So it's equal y prime equal to 1 multiplied by z to the power 0. So y prime equal to 1. Any variable with power 0 equal to 1. It's like a note. Any variable with power 0 equal to 1. Not only variable, it's only constant, also constant. Sorry. Also constant. Any variable or constant with power equal to 0, the results will be 1. We take it before in the first month. We take it before with the exponential rules. So the results y prime equal to 1. So I will take it as a special case. Any variable with power 1, its derivative will be 1. Okay? Any variable with power 1, its derivative equal to 1. The second rule, it's y equal to x underscore. Y equal to x underscore. Okay. Its derivative will be 1 over 2 multiplied by x underscore. So, if I want to take another example, or if I want to take another example, I said number 3, y equal to z underscore. So its derivative will be 1 over 2 multiplied by z underscore. It's a rule. You have to save it in your mind. Okay? So if I had a variable under a square, its derivative will be 1 over 2 multiplied by the same variable under square. The third rule I have here, it's complicated, but we will explain it. If I have variable under any root, but the variable is with power. If I have variable under any root and with power, what its derivative will be? So its derivative will be here n equal to root, m equal to power. Here n equal to root, m equal to power. So its derivative will be the power, here is the power, over the root multiplied by the same root. Under the root we have the same variable with root with power, root minus power. Okay? This is power. N minus m is the new power. The new power will be the root minus the power. We will explain it in example. An example. Okay, we will take an example. The example was said sorry. Example, x under the fourth power. X under the fourth power, y equal x under the fourth power. Its derivative will be the root equal to what? The root equal to what? The root equal to n, and the power equal to m. Sorry. The root equal to m, the power equal to m. Okay, now here the root equal to 4, the power equal to 1. So if I go back to the rule said the power over the root multiplied by the same root under the root, the variable to the new power equal to n minus m, root minus power. So I will solve it for the same rule. So I will put the power in the denominator. Put the power in the denominator over the root multiplied by the same root, x to the power n minus m. So if I want to solve it like this, y prime equal to the power equal to what? 1. So I put 1 over 4 multiplied by the same power, multiplied by the same root, the fourth root, x under the root, x to the new power n minus m, root minus power. So 4 minus 1. 4 minus 1. Okay. Now y prime equal to 1 over 4 multiplied by the same power, the same root, fourth root, x to the power 3. This is how we solve a variable under a root with a power. Also, we have a second way. Also, we have a second way to solve for like these functions. Second way, I put the same function. If you want me to solve it not like the rule I give it to you, I will transform it to x to the power 1 over 4. 1 over 4 power over root. Okay? If I want to solve it like any variable with a power, if I want to solve it like any variable with a power, I will transform it to the power over the root. Okay. If I had like this function, how I can solve it? I said y prime equal to the same power multiplied by the variable to the power minus 1. Okay? It's like the second rule. It's like this rule, the second rule. Okay? It's like potential rules. Okay. Now, if I want to solve it, I said I transform it to a variable with a power. I get rid of the root. So y equal to x to the power 1 over 4. Why 1 over 4? Because the new power is equal to the power over the root. Okay. If I want to take the derivative of this function, I said y prime equal to 1 over 4. 1 over 4 is the new power multiplied by x to the power, the same power 1 over 4 minus 1. Always I said minus 1. So y prime equal to 1 over 4 multiplied by x to the power 3 over 4. Okay. Minus 3 over 4. So in the exponents, I don't accept the negative exponents. If I want to get rid of this negative exponents, I will replace the variable from numerator to denominator, like that. y prime equal to 1 over 4 multiplied by x to the power 3 over 4. Okay, if I want to get rid of the negative exponents, I move it from numerator to denominator. So if I want to take the basic shape of x to the power 3 over 4, I said y prime equal to 1 over 4 multiplied by the root, this power, okay, multiplied by root, the fourth root, x to the power 3. So if I want to see if if I want to see if my solution is right, I go back to the same rule. I go back to this rule. I go back to this rule. If it is equal to this rule, where is it? Yes, it's equal to this rule. So I said to you, the two rules, the two ways are equals. The two ways are right. Every way you want to solve by it, it's